All right, for this video, we're going to be talking about transformations of functions. We're going to look at it mainly when we're talking about the transformations of the equation, but we are going to look at some things graphically when we do the examples. So I have a general function here. I've labeled it f of x, and we're going to talk about all the different types of transformations that can occur. So when I'm looking at the problem, I'm going to talk about order in just a little bit, but we're going to just start at the very beginning, and we're going to look at our first value. So that negative in front. Now, the negative in front or the a in front are equal in value as far as doesn't matter which one comes first when you're stating them, but it does matter that they are separate. So the negative in front is going to tell me that I am going to have a reflection, and that reflection is going to be over the x-axis. So if I have a negative in front of the function, it is a reflection over the x-axis. That a value in the front is going to make my graph look skinnier or fatter. It's called a dilation, and this is called a vertical dilation. Now, that vertical dilation has two cases, and those two cases are going to happen when that a value is a certain number. So if my a value is greater than 1, okay, then I have a vertical stretch. So a vertical stretch will actually make it look skinnier, because if you think if I stretch it vertically, that means that I'm going to stretch out the top and the bottom, which will make it look skinnier. But it's going to be a vertical stretch by the a value. Now, if I have a value that's between 0 and 1, then that is considered to be a vertical compression. And that vertical compression is by the same value. Okay, so again, we have the negative and the a in front. One is going to be a reflection, one is going to be a dilation. So then we come to this inside. So we have another negative and another value that's being multiplied. So this is in front of the function. This is inside the function. Front of the function, inside. Now the inside, I'm going to kind of give you this scenario I like to always tell my students. Whenever you're talking about the values inside the function, I like to say that they're inside the function with the x value. So if they're inside with the x, okay, so I'm going to kind of relate this to x's. Everybody has a boyfriend or girlfriend x, and they're your x for a reason, because at some point they did something, whether it was crazy or whether you just didn't agree with, that you didn't want to be their boyfriend or girlfriend anymore. So anything that's in the inside with the x is opposite of what you think it is, okay? So we're going to start with the negative in front. So the negative for the original one was a reflection over the x-axis. So this negative is going to be the opposite. This one is going to be a reflection over the y-axis. So it's the opposite of the other. All right. Now, this is where we're definitely going to be, you're going to have to pay very close attention here. So then I have the b value, that value being multiplied. This is also going to be a dilation. This is a horizontal dilation, okay? Now, this horizontal dilation is going to work very similar to the vertical dilation, but it's the opposite of what you think it is. So if my b value, all right, so if my b value is greater than 1, then I have a horizontal compression. So it's the opposite. Now, it's not going to be by the value of b. We're actually going to use the reciprocal. So we're going to do by 1 over b. Now, if my b value is greater than 0 but less than 1, then this one's actually going to be a horizontal stretch. And we're going to do by the reciprocal. We're going to do the opposite. So by 1 over b. And I'll show you a few more examples of that when we look at the equations in a minute. All right, so those are the values, that the negative and the b that are in front. Now inside, like inside with the x, we have a minus h. So these have all been multiplying. We're multiplying by negative and a in the front. We're multiplying by negative and b on the inside. Now we're doing some addition and subtraction. So if we're adding and subtracting on the inside, that's going to tell me to go either to the left or to the right. Now, these are opposite. So we would normally think, okay, positive is to the right, negative is to the left. Well, this is the opposite because it's inside with the x. So if it's to the left, it's actually going to be positive. If it's to the right, it's actually going to be negative. And then finally, we have our k value. Our k value is at the very back of the function. And that k value tells me whether we go up or down. And we're going to take that at face value because we're not inside the function anymore. If it's up, it's positive. If it's down, it's negative. Now, the one thing that I will say is when you do this and when you order your pieces, you're going to do the inside first. So you always do the inside of the function. Then you go to the front of the function. Then you go to the back of the function. The k value is always last. So we do the inside. We always do the innermost. So we always do left or right first. Then we do the b and the negative if there is any. Then we go to the front. So the front is the negative and the a. And then the back is the k. So when we list these things, we always do it in that order. All right. So looking at the example here. I was looking at this earlier and I was writing these out. So I was trying to show you and identify the pieces. So the first thing that you should always do is you should always identify the parent function. So your parent function in this particular problem, I have a 2, a 3, and I forgot to highlight my 9 here. And this whole problem has a squared. So with the parent function is y equals x squared. So if I start in the inside, okay, so the inside of my function is x minus 3. So minus 3 means to the right 3. So then I'm going to go to the front. So then I'm multiplying by 2 in the front. That's going to be a vertical stretch by 2. I know it's a stretch because it's greater than 1. And then finally, we go to the back of the function. So plus 9, that's outside of the function. So that's going to be up 9 units. All right, so looking at the next one, number 2. The parent function for this one is going to be the square root function. So my parent function here is the square root. So when I look at it, I have the 1/3 on the inside, I have the negative on the front, and I have the minus 9 at the back. Okay, so we start from the inside, so 1/3. This is going to be a horizontal dilation. Now here's the trick. I have 1/3. 1/3, if it's horizontal, falls between 0 and 1. So 1/3 is going to be a horizontal stretch. So this is going to be a horizontal stretch, but we do the reciprocal. So it's not going to be by 1/3. It's going to be by 3/1 or just 3. So let me say that again. It's a horizontal stretch because 1/3 falls between 0 and 1. But we call it a stretch by the reciprocal value, which is going to be by 3. All right, so then we go to the front of the function. So in the front of the function, we have that negative. So that's going to be a reflection. And that's going to be a reflection over the x-axis. And then we go to the back. And at the back, we have down 9 units. All right, so the next one, we have those 2 bars that are on each side of the function, which means absolute value. So my parent function here is the absolute value. All right, so when I'm looking at this, I'm going to start in the very innermost part, which is going to be that times 5. And that times 5 is going to be a horizontal shrink this time. Why is it a shrink? Because if I go look at my rules, 5 is greater than 1. So right here, 5 is greater than 1. So it's a horizontal compression or shrink. All right, so we're going to do a horizontal compression. But remember, when we state this, we have to do it by the reciprocal value, so by 1/5. All right, so we did that part. Now we're going to go to the front. So that negative in the front is going to be a reflection over the x-axis. And then finally at the back, I have plus 3, so that's going to be up 3 units. All right, for this one, it is actually the reciprocal function because it's going to be 1/x. Now, we're gonna really have to think about what's considered inside, what's considered the front, and considered the back. So what I'm gonna do is I'm actually going to rearrange this. This is the same thing as -3 times 1 over x plus 1 plus 5. So if this is my parent function, then the inside is going to be my actual denominator, because that x was in the denominator initially. So we're going to start with plus 1. Plus 1 means that we're going to go to the left 1 unit. Then in the front, we are multiplying by 3 and a negative. So we're going to have a reflection over the x-axis. All right, and that multiplication in the front is actually going to be a vertical dilation. And that dilation is going to be a vertical stretch. And we take that at face value, so by 3. And then finally, the plus 5 at the back is going to be up 5 units. Okay, so let's kind of look at these in the calculator right quick. All right, so if I'm looking at these values, so we'll start at the top. So I have y equals x squared, and we're gonna build this for each piece. So we started with x minus 2, and there we go. And I forgot my equals, so let me go add that back in. So we can see that did. So we went from red to blue. So red to blue, we did go to the right by, and that should be 3 units instead of 2, so 3 units. So then from there, we went to the front of the function, which we said was a vertical stretch. So if I stretch it vertically, that means I'm pulling the top and the bottom vertically. So we're changing the y values. So that's going to make it look skinnier. And then finally, we're going to do plus 9, which means we went up 9 units. So you can see that we start at 0, 0. Now the vertex is at 3, 9 because we went to the right 3 and up 9. All right, same thing here. So we have y equals the square root of x. That's my parent function. So in the inside, we're going to do a horizontal stretch. So it's actually going to make it look bigger. So we're going to do the square root of 1/3 x. And you can see that did make it bigger, okay? And then we did the negative in front, which is going to be a reflection over the x-axis. So it's going to physically, going to flip over that x-axis, okay? And then we are going to go minus 9, which means we're going to go down 9 units. So you can always check yourself in the calculator and look at your pieces. So y equals, so we have absolute value. There's my absolute value. So we start on the inside. So we have y equals the absolute value of 5x. You can see that made it a vertical stretch, which made it look skinnier. Then we're going to reflect over the x-axis, and then finally go down 3 units. Now, go up 3 units because it's plus 3. So all of these things are things that you can look at as far as your functions. All right, so one more. So I have y equals x squared again. I have 1/2 being multiplied in the front. So 1/2 is in the front. There's no parentheses to indicate that it's inside. So this is going to be a vertical compression. And I know it's a compression is because that a value is between 0 and 1. So by 1/2. And then plus 1 means we're going to go up 1 unit. Now, what happens if I don't have a parent function? I ask you to transform the function even more. So I have the square root of x minus 3 plus 4. So initially, we're going to the right 3 and up 4. So they want us to transform it even more. They want us to do a reflection over the x-axis. So that means I'm going to put a negative in front. Okay, so we're going to put a negative in front. We're going to do a horizontal shift. So that means left or right so right 3 units. So if we think opposite, we're actually going to be subtracting 3 here. So we're going to come here and we're going to subtract 3 more units. So my new transform function is y equals negative square root of x minus 6, because negative 3 minus 3 is going to be minus 6 plus 4. Because we've already went to the right by 3, we're going right more, so now it's going to turn to 6. All right, so looking at this one. So I already have, I'm going to the right 2, I have a reflection over the x, and I have a vertical stretch by 4. So now what they want us to transform it to is we want to go to the left by 2. So left by 2 means we're going to add 2. So we're going to add 2. And then a vertical shift of down 4. So down 4 means I'm going to do minus 4. So we're going to add on minus 4 over here. So when we transform this, it's going to be minus negative 4. And then I have negative 2 plus 2. That's going to equal 0. So I don't even have to put that inside piece anymore, because it equals 0. And then minus 4. Now, if you have any more questions about transformations, just let me know. But the key here is to always look at your rules, and those rules, you definitely need to know those.